For section 5.5, we're going to deal with exponentials that have a base other than e. So remember, if I take the derivative of an e to them, I write what's sitting there times the derivative of the exponent. Okay, that's going to be the exact same thing we do here. So if I have a base like 2 or 15 or whatever, as long as it's not e and my variable's in my exponent, then the answer is write what's sitting there times the derivative of the exponent times the natural log of the base you were given. So this is actually the exact same formula as this, but if I put a natural log of e right here for the base, then it goes to 1. Another one is going to be this one. So what happens if I have a natural log? The derivative of a natural log is the derivative of the argument over the argument itself. Well, the derivative of a log with a base other than e is going to be the derivative of the argument over the argument itself times the natural log of the base that's not e. So again, if I had evaluated that as a natural log of e, then I would end up getting a 1 right there. So it's the same formula, you're just multiplying or dividing by the natural log. Down here, when we integrate, if I'm going to integrate a to the u, it's going to be along the same lines of what I did. I'm going to get an a to the u plus c. So as long as my exponent is balanced, I'll be fine. But the difference, again, is going to be you're going to divide by the natural log of a. So the logarithm formula is not down here, but it is here. Okay? So if you've got the derivative of the bottom over the bottom times the natural log of the base, then you would integrate back up to the log of the base of u. Okay, so it's there. You can work this backwards. All right, so that being said, what is going on? I have, ignore all this mess right here. I've got f of x equals 7 raised to the x power, and I'm supposed to take a derivative. So what did we learn? We learned if I have a base other than e, then I'm going to write what's sitting there times the derivative of the exponent times the natural log of the base I'm using. Okay, so write what's sitting there times the derivative of the exponent, which is 1, times the natural log of the base, which is the natural log of 7. Okay, so 7 raised to the x power times the natural log of 7. That's the derivative of 7 raised to the x power. So let's do it again. We have y equals 3 to the negative 4x power. So I notice that my base is 3. I know that my variable is up in the exponent. So again, don't use power rule. Do not add 1, divide by your new exponent. Don't do that. This is a different format. So what is my derivative? My derivative is to write what's sitting there, okay, times the derivative of your exponent. And you're going to need to put that in parentheses. Okay, so negative 4. So I've got a negative 4 times 3 raised to the negative 4x. Okay, so write what's sitting there times the derivative of the exponent times the natural log of the base. That needs to be in parentheses. Otherwise, it looks like a negative 43. Okay, order doesn't matter in multiplication, so you can have this term times this term times this term, whatever. Just make sure you got your parentheses where they need to go. All right, so I've got f of x equals x times 2 to the x power. So I've got variables times variables. So my derivative is going to be the first times the derivative of the second. So write what's sitting there times the derivative of your exponent, which is 1, times the natural log of the base, plus the second, which is 2 to the x, times the derivative of the first, which is 1. So he's done. All right, number 4. So I've got f of t equals 2 raised to the 8t power over t. So I've got variables divided by variables, and I can't simplify it at all. And so I am going to turn around and do quotient rule. So I end up with my derivative is the bottom times the derivative of the top, which means I write what's sitting there times the derivative of my exponent times the natural log of the base. So I've got first times the derivative of the second, okay, plus the second, which is 2 to the 8t, time, what am I doing? Bottom times derivative of top, I'm so sorry, minus the top times the derivative of the bottom, which is 1, all over the bottom squared. So my mouth just went to product rule. I don't know why. And again, make sure that this is in parentheses just to distinguish the fact that this 8t only belongs to the 2. Okay, it does not belong to 8t times 2 raised to the 8t. Okay. All right, so the next one we're going to do is I'm going to take the derivative of a log in a base other than e. So I've got log of 8, or log 8 of x squared minus 5x. And again, if you want to, you could factor this to x times x minus 5 and then separate that out into 2 different functions. But really, this is not that difficult. Okay, so my derivative is going to be the derivative of the argument, which is 2x minus 5. Hang on, I just totally lost what I was doing. My brain is not working today. When does my brain ever work? All right, log. So the derivative of the argument over the argument itself times the natural log of the base. So the argument itself is x squared minus 5x times the natural log of the base. Okay, so you got natural log of 8. So again, you could have put the natural log of 8 at the end. Just make sure you put this mess in parentheses because that natural log of 8 belongs to both terms. Okay. So I keep saying K. I've got, let's do more stuff. So I've got y equals log 3 of x squared minus 9. So I'm in log world. I'm going to go ahead and drop this power because it's a square root, sorry. I'm going to drop that power out front. So really and truly, this says log 3 of x squared minus 9 to the 1/2. So I'm going to rewrite, I am not doing calculus, of log 3 x squared minus 9. Now that derivative, remember this is one big fat term. Okay, so it's log base 3 of this mess times 1/2. So 1/2 is coming along for the ride. So I've got a 1 over a 2, or you could just lead off with 1/2, and I'm going to leave my 1 unwritten because I don't need it. So the derivative of the argument is 2x over the argument itself, which is x squared minus 9, times the natural log of the base, which is the natural log of 3. And these 2's reduce out, which is awfully handy. So this is your final answer for that one. All right, we have h of x is log base 8 of x times the square root of x minus 6 over 7. Okay, so I'm going to go ahead and separate this thing out. So if it's joined by multiplication on the top, remember I can write that as an x minus 6 to the 1/2 over 7. Okay, so I've got, just rewriting, I've got log base 8 of x plus 1/2, because I dropped the 1/2 out front, x minus 6. I'm sorry, y'all. My brain is absolutely shot. Hang on. I am rewriting this as, okay, log base 8 of x plus log base 8 of x minus 6 to the 1/2, which I can drop that 1/2 out front as a common constant multiple, minus log base 8 of 7. So now I can just go in and take a derivative. So my derivative is going to be the derivative of the argument, which is 1, over the argument itself, times the natural log of the base, plus, okay, 1 over 2, there's your 1/2, derivative of the argument, which is 1, over the argument itself, times the natural log of the base. Okay, so you got this one plus this one, and then the natural, or the log of 8, 7, is going to be 0, because this is just a number. It's a constant multiple, so that goes to 0. So this is your final answer. I have All right, so I'm going to find the equation of the tangent line to the graph of the function at the point 7, 1. I'm going to try and get two more. Yeah, I can do this. All right. So I get y equals 5 raised to the x minus 7. And when I have that, I have an x value and a y value, but I need an m in order to find the equation of the tangent line. So take a derivative, which is y equals the natural log of the base times what's sitting there times the derivative of the exponent, which is just 1. Okay, so this is a weird number. That's my formula for slope. If I shove in a 7, what do I get for an answer? So 5 raised to the 7 minus 7 is 5 to the 0, which is 1. So my m is 1 times the natural log of 5. Okay, so this is going to get slightly messy. I've got 7 comma 1 natural log of 5. Oh no! All right, so 7 comma 1 times the natural log of 5. So I have, and my m is the natural log of 5. You can get a decimal approximation for that, but we're not going to do that. So my equation of the tangent line is going to be y equals mx plus b. So I've got 1 equals the natural log of 5, which is a number. Okay, so there's m. Your x is 7, so I'm going to put a 7 here, plus b, which means your y-intercept, I just need to subtract this number over, which is a very ugly number. Okay, but it's a number. So I end up with an equation of a tangent line of y equals m, which what was my m? Natural log of 5, times x. So you can put your x at the end or put it out front as long as that 5 is in parentheses and the x is not in there. So this number times x minus, or sorry, plus my b value. Well, my b is 1 minus 7 natural log of 5. And you're done. Okay, it's ugly, but that's the equation of the tangent line. All right, so the next one, we're going to use logarithmic differentiation to find the answer. So I have y equals x raised to the 2 over x. So this time I got variables in 2 places, and I can't do product rule, quotient rule, anything like that. So I'm going to go back to logarithmic differentiation. So I've got the natural log of y equals the natural log of x raised to the 2 over x. Okay, that is raised to the 2 over x. Lord help me, I'm messed up. All right, so since I'm in log world, I can drop this out front as a coefficient. All right, so hopefully that makes sense. All I did was take the log of both sides. I have not done calculus yet. So now, hang on. Yes, I took the log of both sides. Now I'm going to take a derivative. Goodness. I've been doing videos all day. All right, so I get the derivative of the natural log is 1 over itself, or 1 over the argument dy. This needs quotient rule. So I've got the bottom times the derivative of the top. So remember, 2 is coming along for the ride. And then you've got the derivative of the argument over the argument itself. So I've got the bottom, which is x, times the derivative of the top minus the top times the derivative of the bottom, which is 1, all over the bottom squared. So when I clean this up, those x's go away. So I've got a 1 over y dy. I took the derivative of x, so put a dx on there. And then this ends up being 2 minus 2 natural log of x over x squared dx. So divide both sides by dx. Multiply both sides by y. So I've got 2 minus 2 natural log of x over x squared times y. Well, do I know what y is? I do know what y is because that's what I started with. So dy dx equals 2 minus 2 natural log of x over x squared times, well, what is y? X raised to the 2 over x. And that is it. So it's ugly, but that's your answer.